Hello, this is FlippedHarber for Precalculus. In this video we're going to cover section 6.5, the inverse trigonometric functions. The objectives for this lesson are to find the exact value of an inverse trigonometric function and find the approximate value of an inverse trigonometric function. The outline for this video, we'll talk about the inverse sine function, the inverse cosine function, the inverse tangent function, and then we'll talk quickly about the remaining inverse trigonometric functions. We're going to talk about finding the exact value, that is, using the trig table. We're going to talk about finding the exact value when, crap, it's not on the trig table. And then we'll talk about how to find it on your calculator. Now, the inverse sine function is a function that I like to say that it undoes a sine function. So there's a pretty important idea in mathematics that for every function, for every operation that we can do on a number, we need to be able to undo that. Now, you know, the first reverse operation that you learned was subtraction. So you learned how to add two numbers together, and then you learned the opposite of that. You learned to subtract. With multiplication, you learned division. And then it went on from there. When you square a number, to undo it, you take the square root. Well, these trig functions are no different. We want to be able to undo the changes. We want to be able to move that trig function out of the way. And really what I'm talking about doing is solving equations, which is our next section for the chapter. So, first of all, that's read y equals sine inverse x. Or another way to say it is y equals arc sine x. And some books actually write it arc sine, A-R-C-S-I-N. The reason they do that is you see that negative 1 in the power location and you think, oh, it's 1 over the sine. No, no. 1 over the sine is the cosecant. That negative 1 is there to imply the opposite function. Okay, the inverse function. Just like when we put a negative 1 on a function notation, it doesn't mean 1 over the function, it means the inverse. So y equals sine inverse of x means that x is equal to the sine of y. Okay, they are opposite operations. Now, you know, we can only get out negative 1 to 1 whenever we take the sine. The sine only moves back and forth between negative 1 and 1. We limit the where we look at an inverse sine to only between negative pi over 2 to pi over 2. And we'll talk about why kind of with the next chapter. But let me just tell you this. If you get out your trig table and take a look at your trig table, I shaded a region in each column. And you'll notice that in the sine column, the region between negative pi over 2 and pi over 2 is what's shaded. So that's really where you need to be working today when we're talking about inverse sine function, is you need to be in that shaded region. Boy, that was kind of nice of me. Okay, let's move on to some more things about the inverse sine function. As I said, it undoes the sine function. So if we take the sine inverse of the sine of u, they cancel each other out, just like the square root and the square cancel each other out. And it doesn't matter which one we do first. If we take the sine inverse of the sine, they cancel each other out, but it goes the other way. The sine of the sine inverse, they also cancel each other out. Now take a look at where u and v can be. Since the sine is operating first on u, that means that u is an angle. That angle needs to be between negative pi over 2 and pi over 2. But in the bottom one, the arc sine, the sine inverse, is operating on v first, so that means that v is a regular number. It has to be between negative 1 and 1, or else that inverse sine can't work on it. Okay, now, the inverse cosine function, almost exactly the same. It's the opposite operation of the cosine. It's going to get rid of the cosine. It does not mean 1 over the cosine. All that stuff that I said about sine is about the inverse sine is true for the inverse cosine. Except look at what's shaded on your trig table. Y has to be between 0 and pi. So things are shifted around a little bit. It's basically where can we easily get both positive and negative values. Okay, so cosine, we limit y to be the angles between 0 and pi, the first and the second quadrant. Okay, same thing as before with the inverse cosine and the inverse sine. They undo their respective trig functions. So the cosine inverse of the cosine, they cancel. The cosine of the cosine inverse, they cancel. Okay. Same thing going on with the tangent. We've got some different limits though. Notice tangent, like sine inverse, we work between negative pi over 2 and pi over 2. So you'll notice that that shaded region again starts up there at negative pi over 2 and it stops at pi over 2. Okay, so tangent inverse of a tangent, they cancel out. Tangent of a tangent inverse, they cancel out. Okay, last, well, this isn't the last slide. I don't know why I said last, but here's our other ones. Yes, for the cotangent, there's an inverse cotangent. For the secant, there's an inverse secant. For the cosecant, there's an inverse cosecant. Whew. Okay, notice the limits though. Okay, y needs to be between 0 and pi for cotangent, and secant, it needs to be between negative pi over 2 and pi over 2 for cosecant. Okay, so let's get to the nitty-gritty. Okay, I've introduced the concept of what an inverse trigonometric function is. Let's actually get to how do we use these things to solve problems. So, as I said before, your trig table has a shaded region in each column. Make sure that when you're finding inverse trig functions, only use angles from that shaded region. So, if you're asked the cosine inverse of -1, the first thing you should do is consult your trig table. Go to your trig table, look in that shaded region. Can you find -1 in the cosine column? So notice we're not starting at the angle and moving over to the cosine column. We're starting in the cosine column and we're looking for a -1 in that shaded region. So we see where the -1 is in the shaded region. It can be found at theta equals pi. So the cosine inverse of -1 is equal to pi. That wasn't too bad, was it? Well, what about this one? Holy crap! Now, obviously, this tangent and this sine inverse do not cancel. I did not make a typo here. I am actually asking what is the tangent of the sine inverse of -1/2. So this is a number. The sine inverse operates on it and turns it into an angle. So this is an angle that I then want to find the tangent of. So this is going to be a two-step process with our trig table, and it's 2 easy steps, trust me. Go to your sine column. In the shaded region, find -1/2. Now, from that row where you found that -1/2, read off the tangent value. I'm not even asking what is the angle. Go find that -1/2 in the sine column in the shaded region. Move over a couple rows to the tangent, a couple columns to the tangent in that same row and write down the number. So, you do that, you're going to end up in the angle -pi/6. I don't really need to know that on your homework. You go over to the tangent column in -pi/6 and you get -√3/3. You do not even need to show me this work. I'm expecting you to go find -1/2 in the shaded region of the sine column and then move over to the tangent column and just read this number off. Okay? Now, what about when you're asked to find the exact value and holy crap, it's not on the trig table? Look all you want, you won't find 1/3 in the cosine column. So what do? Well, first let's take a look at the cosine inverse. And now I do need to see some work from you. Remember, this is a number. This is an angle. The cosine inverse of 1/3 is going to spit out an angle. Let's call that angle theta. Or let's just go ahead and say that the cosine of theta equals 1/3. You smell that? I smell a triangle. Here's theta, adjacent over the hypotenuse. So how am I going to find the tangent of theta? Well, I need to find this opposite side. Pythagorean's theorem. Shaboom. So now the tangent is equal to 2, square root of 2. Well, that should be a 1. I don't know why it says 3. Oh well. It's supposed to be 2 square root of 2 over 1. Make sure you write it down in your notes properly. I'm not going back and fixing it now. Alright, so the only thing that we really haven't covered is what about in a calculator? Well, I can't tell you all the secrets right now. So, get started on that homework, and I'll see you in class and I'll see you online.